Hello mathematicians. This video is about how to analyze a graph using interval notation. So interval notation is used to describe a series of points in a row, almost like inequality notation is. So for instance, for this graph, we're trying to figure out the domain. Domain is all the possible x values for the function. The smallest value in the domain is -6. And the largest is 11, and it's continuous throughout. There are no x values in between that are not in the domain. So we are going to express that using the x coordinates. So it's between -6 and 11. Because it is a solid dot at -6, that means -6 is included in the domain, and therefore we'll describe it with a bracket using interval notation. The same is true for 11. That's a solid dot. That means that point at 11 is included in the domain. So that's going to be a bracket. If this was an open circle, meaning that 11 was not in the domain, but everything up to 11 was, this would be a parenthesis. But because it's a solid dot, it's a bracket. Okay, so the range is the set of all possible y values. So range is the only time you use interval notation and that the numbers you're using represent y values. So the smallest y value on this graph is -3, and the largest y value is 4. So the range is continuous throughout from -3 to 4. Because it's a solid dot, where it's -3, it's a bracket, and where it's a solid dot, where y is 4, it's also a bracket in interval notation. Now we want to figure out where the graph is positive. So it's positive wherever the graph is above the x-axis. Okay. On the x-axis, it's neither positive nor negative. So remember, we're going to use x values for our interval. So it goes between -3 and 6. But it's not positive at those points. It's 0, which is neither positive nor negative. So we're going to use parentheses to describe it. So it's positive between -3 and 6 with parentheses. In union with this piece here. So at 10, it's neither positive nor negative because it's sitting on the x-axis, so it's going to be a parenthesis at 10. But at 11, where the function ends, the y value is positive, so we're going to do 11 bracket. The union tells us that there's two separate intervals that we're combining. The graph is negative below the x-axis, so it's going to be negative between -6 and -3. At -6, the graph is clearly below the x-axis, so it's going to be a bracket. But at -3, that's an x-intercept, and the y value is 0, which is not negative, so we're going to do parentheses. In union with, it is negative in this piece as well, and this is between two x-intercepts, so it's going to be parentheses 6, 10 parentheses. At 6 and at 10, the y value is 0, which is not negative. Then where is the graph increasing? So the graph is increasing wherever, if you're walking on it from left to right, wherever you're going uphill. So this piece right here is increasing, as is this piece here. So we'll describe that as between -6 and 2. So in your book, on your online homework, I believe they say that it is increasing at -6, so they have a bracket. Myself, personally, I would put a parenthesis because I think of this as being still at this point. But since your homework is online and the online homework uses a bracket, we'll use a bracket. But technically, I would accept both if it was a written test or quiz. And they would also have a bracket at 2. Then there's this piece here, so it's in union with 8 to 11, bracket. Okay? It is decreasing in between, that interval in between, so that would be between 2 and 8. Again, online resources will have that as a bracket. The graph here is not constant over any interval, so I'm going to put does not exist. It's hard to do this to show you. I have to move my camera, sorry gang. And then we have a few more questions about the graph. It's hard to see the graph and the questions, so bear with me. And then the next question is to list any x-intercepts. So that means list them as points. So -3, 0, comma, 6, 0, comma, 10, 0. The y-intercept appears to be 0, 3. Of course, there can only be one y-intercept if there are any. If you had more than one y-intercept, it would not be a function. The next question is, how many times does the line y equals 3 touch the graph? So y equals 3 is a horizontal line, and that horizontal line happens to go through these 2 points. So the answer is twice. Okay, you don't have to bother telling me where it is, but that's where. All right, 2 words that may be new for you: relative extrema and absolute extrema. Sorry, my Amazon purchased document reader isn't great with big pieces of paper. Relative extrema, so that's relative maximums and relative minimums. Okay, so here's how I describe those. I use non-math terms. So for instance, Mount Washington is a relative maximum. Mount Kilimanjaro, relative maximum. Mount Everest, absolute maximum, and also a relative maximum. So a relative maximum is the same thing as a local maximum. It's the highest point in the area for a graph. So on this graph, we have a relative maximum at 2, 4. Oops, you can't see it. At 2, 4 is a relative maximum. It also happens to be the absolute maximum. So it's a relative max and an absolute max. Now, important thing about the definition of a relative or local maximum. It's also called a local max. The formal definition of a relative maximum is that a point on the graph where the function goes from increasing to decreasing. So at 2, 4, this function goes from increasing to decreasing. So over here at 11, 1, this is not a relative maximum because it goes from increasing and then it stops. So the only relative max here would be at 2, 4, the point 2, 4. Now when I write that out as 2, 4, that's not an interval, that's a point. Okay? Intervals can look like points, but really that's a point. That's the only relative maximum there. For relative minimums, we have 1 here at 8, -2. So this is a relative min, and it's not an absolute min. The absolute min is over here at -6, -3. So this is not a relative minimum because the definition of a relative minimum is a place where the function goes from decreasing and turns into increasing. So it's either a hill or a valley to be a relative max or min. So this -6, -3 is what we would call the absolute minimum. So the relative minimum is at 8, -2. The absolute extrema, the absolute max, is at 2, 4, and the absolute min is at -6, -3. Not every graph has these values. These are sort of unique to this particular graph. Not every graph has all of those characteristics. Thanks for listening.